In this lesson, we take a look at the transmission section of the standard surface shader. For this lesson, we have this glass and this bottle object, and we're going to see how transmission parameters work. Also, we still have our shader ball geometry, which we are going to be using it later on to test some of the transmission parameters. Let's open up the standard surface shader that I have applied to this bottle and glass object, which is this one, and also open up the transmission section. Transmission basically allows light to scatter through the surface, so you can create refractive or transmissive materials such as glass, water, honey, bubbles, and so on using the transmission section. The first parameter here is obviously transmission weight, which controls how much transmissive or refractive you want the shader to be. At 0, you have basically no refraction and only base color and specular reflections, as you can see in the IPR. And if I actually run the IPR, so as I'm increasing the transmission weight, now we start to introduce more refractive quality. And because the standard surface is energy conserving, increasing the transmission weight will result in ignoring the base color weight gradually. So if I just start increasing the transmission weight, you can see we add more and more refractive quality. And at 1, you can see now we have a fully transmissive or refractive object. Also, you notice because of this energy conserving material, which does it automatically in previous version of Arnold, we need to kind of make sure that we set our parameters in a way that they are energy conserving. But in the newest version of Arnold, as you can see in Arnold 5, as we set our transmission weight to 1, the base weight is disabled to make sure that the material stays energy conserving, which is really cool. Now at 1, as you can see, now we have a fully refractive or transmissive object, but as you can see, we have this very dark shadows or this very dark parts on our transmissive objects, and that is because, as I mentioned, the opaque option for these objects is on. And if I actually right click on this bottle and go to the C42A tags and add an Arnold parameters tag, I can actually disable the opaque option for the bottle and also for the glass, and this way the shadows cast from the transparent object will look correct. And if there was a refraction or a transmission color that we can set it here, the shadows will pick up that color. Whenever you create a transmissive or refractive object, disable the opaque option so its shadows looks correct. Also, if you see any dark parts in your transmissive object, if it's more complex than the objects that we have here, for example, obviously you need to increase your transmission ray depths. Right now it's set to 8, which is going to be enough for this scene. Now next we have the transmission color, which controls the color of the light when it passes through a transmissive shader. So let me just maybe use something like this and press OK. Basically, this color filters the refraction according to the distance traveled by the refracted ray. The longer the light travels inside a mesh, the more it is affected by the transmission color. Therefore, for example, a green glass gets a deeper shade of green as rays travel through the thicker parts. Naturally, colored glass has different shades of color based on their thickness. Thinner parts will be tinted lighter and thicker parts will have darker shades of the same color. So probably if I use a less saturated version of this green color, we can see that effect a bit better. Now to actually see this, it's a bit visible. You can see, for example, this thick parts have a bit more saturated, darker shade of this green, and this thinner parts are a bit lighter. But to actually see the effect a bit better, we need to actually take a look at the depth parameter as well. Depth basically controls the depth into the volume at which the transmission color is realized. Increasing this value, let's say to something like 1 or let's say 5 centimeters here, or let's say 3, So increasing this volume makes the volume thinner, which means less absorption and scattering will happen. It is a scale factor so that you can set a transmission color and then tweak the depth to be appropriate for the size of your object and control how the transmission color affects the thin and the thick parts of your object. So as I'm increasing this, you can see the contrast between the thinner parts and the thicker parts increase. Right now you can clearly see how this thicker parts have a darker, more saturated shade of this green color that we have defined as our transmission color, and the thinner parts are having a less saturated, brighter version of that color. They are basically not that tinted. Okay, if I use a lower depth value like 1 centimeter, you can see the colors become more even. Okay, let me increase this like to 20 or like something like 4. You can see now the contrast between those thin and thick parts are more obvious. Let me just set the depths to 0 and use a white color as the transmission color for now. Now the next important thing is how to control the roughness of your refractive or transmissive object. Obviously you do that using the specular roughness, because in real world an object has the same roughness for its specular reflections and for its refraction. So if I increase the roughness here, the specular roughness, to something like 0.4, you will notice both the speculars and the refraction will become rougher. So if I, let's say, use something like 0.4, you can see we have both blurrier speculars and blurrier refractions, and we get this kind of frosted look. And if I use a low value like 0.01, now we get obviously this clear glass. But the transmission section have this extra roughness parameter. So for whatever reason, if you want to control the specular reflection roughness independently from the transmission roughness, you can use this extra roughness. So I can, let's say, use an extra roughness like 0.3. Now as you can see, we get this very sharp specular reflections and this very blurry frosted refractions. Let me set the extra roughness to 0.0 and the roughness probably to something like 0.05. Now the next parameter I want to discuss is the IOR, or index of refraction. This parameter not only controls the Fresnel reflectivity that we discussed in our previous lesson when discussing the specular reflections, but it also controls the index of refraction for transmissive or refractive objects. Basically, IOR controls how much light rays will bend as they enter a medium. This value is 1 for vacuum, so the light won't bend in vacuum. If I just set the IOR value to something like 1, take a look at this bottle here. So you can see as soon as I set this value to 1, because the vacuum won't bend the light rays, as you can see we don't get any distortion of the image behind the glass and the bottle. But as I increase this value, let's say something like 1.33, which is the IOR value for water, now as you can see we have a distorted image behind the glass and the bottle. Let's use something like 1.52, which is the IOR value for most household glasses. Or we can use something like 2.41, which is the IOR value for diamond. Let me set the IOR value back to 1.52, which is the default value. Obviously, you can find IOR values for different materials that you want to create on the internet. Now, the next parameter I want to talk about is this dispersion AB parameter, which controls how much the index of refraction varies across wavelengths. At 0, which is by default, the effect is turned off. And the lower the value, the more dispersion the shader would have. Normally you would use a value between 10 to 70 to stay in the normal range. So if I use something like, let's say 10, now as you can see from this render, the dispersion effect is quite obvious, especially in these more detailed parts of our geometries. And if you increase the dispersion value to, let's say, something like 20, the effect will be less visible. So if I just take a snap and increase the dispersion AB value to something like, let's say 40, the effect should be less visible. So here is our render, and if I take a snap and compare the two render, you can see in the first one the effect is a bit more obvious compared to this one. Okay, so this is 10 and this is 70. 10, 70, 10, 70. Sorry, 40. So that's about dispersion app. Let me just zero it out. Now next we have these two important parameters, scatter and scatter anisotropy. Scatter allows you to simulate subsurface scattering for refractive objects and can be used to create shaders for high viscous liquids like honey, caramel, chocolate, or surfaces like ice or pallescent glass. For these two parameters, I'm just going to hide the bottle and the glass and actually unhide the shader ball. As you can see, we have this new liquid geometry, which is going to be very useful to take a look at the scatter and the scatter anisotropy parameters. So what I'm going to do, we have the shader ball geo, the base geometry, and this liquid. I'm just going to make sure they all have the opaque option disabled for them. So I'm going to control drag the Arnold parameters from the bottle or the glass, and as you can see now the opaque option is disabled, and we should be able to see a better render. Let me just run the active shade. Let me just drag a region around this, shift and drag to draw a render region. Okay, now let's just assign these shader to the object. Now if I use a scatter color other than black, let's say something like that maybe, and now increase the depth to something like 1, and as you can see we have created a shader that can be used on a viscous liquid like caramel or honey. Obviously we need to adjust the color and the depth value to get exactly what we want. So let me just I have a few color that you can probably use. Maybe let's use this color here, and I'm just going to increase the depth maybe to something like 2, and also increase the roughness to something like 0.2 or 0.25. Also, you know what we can do? We can delete this and just assign the shader directly to the shader ball, because the other geometries have their own shader and we are not going to have any problems. So here is what we have, and we get this beautiful caramel-like shader thanks to the scatter parameter. So if you take a look, the thinner parts are having more refractive quality and less subsurface scattering quality, but the thicker parts like here have more subsurface scattering and less refractive quality. And this is what's happening in real world viscous liquids like honey or caramel or chocolate. And you can, depending on the exact look that you want, you can adjust the depth and the scatter parameter. For example, if I increase the depth value, we are gonna see basically less contrast and more refractive quality. So if I, let's say, increase the depth value to something like 4, now as you can see from the IPR, we have less contrast and the material looks more refractive in general. And obviously you can change the scatter color to exactly what you want. It really depends on what you're trying to create. Okay, let me just set this to 2, probably use this color for now. Next we have the scatter anisotropy. The scatter anisotropy is a direction bias or anisotropy of the scattering. The default value of 0 gives isotropic scattering, so the light is scattered in all directions. Positive values bias the scattering effect forward in the direction of the light, while negative values bias the scattering backwards towards the light. So you can experiment with these parameters to see how it can help you to get the exact look that you are after. And finally, let's create something like a chocolate or caramel. I'm going to be using this color. Let me decrease the depth to something like 0.5. Or even 0.2 maybe. Let me just render region dissection to see how it looks. It's probably, let's try 0.3. Probably it's gonna look a bit better. Let me check out this section here. The roughness of 0.2 should be enough. And yeah, I think this is going to be a nice looking kind of chocolate shader. We can obviously assign a bump map or a specific specular roughness and transmission roughness to make it more realistic, but you can do that on your own. So let me just, I think this is going to be enough. I'm probably going to use a depth value like 0.25 in between, and let's increase the render settings. I'm going to use the camera samples like 5, diffuse sample like 4, specular and transmission samples of 4 as well, and the Arnold sky has a sample of 4. Now let me just go ahead and render this, and when it's done I'll be back to take a look at the results. Okay folks, so here is our final render, and we have this beautiful chocolate shader that was made possible by the depth and the scatter parameter in the scatter section of the standard surface shader. So that was the transmission section of the standard surface shader. I will see you in the next lesson.